I am Vaibhav Srivastav from Vaibhav E-Learning Academy. Today we are going to continue our topic Newton's laws of motion, and this is our part number 4. In today's video we will be discussing about pulley problems. What is a pulley? What are the different kinds of problems in pulley? We will be talking about fixed pulley, movable pulley, and also we will be discussing about a special type of pulley arrangement called Atwood's machine. Atwood's machine. So what is this Atwood's machine? Now, for understanding this concept of pulley's problem, you need to understand about the Newton's second law of motion, because there we have learned how to make the equations. Even here I will be explaining how to make equations, but there I have explained it in detail. So first, what is Atwood machine? Now, what is a pulley first of all? Imagine this is a rigid surface. Rigid surface is a fixed surface. From there you have a bell like thing, like it's rolled, and here there is a rope which is rolled around the bell. This is called a pulley, and here there is a mass M1 and here there will be a mass M2. This is called a pulley, and this two-block pulley system. Two-block pulley system is called an Atwood machine. So this two-block pulley system is called Atwood machine. Now what happens in this? So in this kind of problems, in basically this specific case, what happens is M1 or M2, any one mass will be heavier and the other mass will be lighter. So due to the force of gravitation, the heavier block comes down. So suppose M2 is greater. Here if you assume M2 is greater than M1. So what will happen? The heavier block will start coming down. As this comes down, the string. So what is this? This is the pulley and this is the string. So as this M2 block comes down, the string gets pulled, and as the string gets pulled, from this side it gets pulled from the top of the pulley and from here. So if this M2 moves down, this M1 moves up. For example, this M2 moves down with a velocity v. The M1 block moves up with the same velocity v. This case is only for fixed pulley. For example, the M2 is moving down with acceleration a. Similarly, that same acceleration, this will also be moving but up. Sign is different. Here minus v minus a, and here plus v plus a. That is different. So this type of machine, this is called Atwood machine, and this whole system is called Atwood machine. This thing is called a pulley system. Now regarding this pulley, we will have to find acceleration of the pulley, tension in the string of the pulley, etc. So for finding the acceleration, we have many different methods. First method is the direct formula method. What is the formula method? Assume this is an Atwood machine. Here is the block of mass M1. Here is the block of mass M2. M1 and M2. Now in this case, assume M1 is less than M2. That is, mass M2 is greater. Now after a particular time t, or as you leave this system, now originally it is at rest. If you leave the system, M2 starts going down and M1 starts going up. So in these kind of problems, first we have to find the tension. And how to find the tension, we learned that in Newton's laws of motion first video. In the case of strings, we put the tension away from the point. So for M2, the tension will be like this, T. And the string is same. The same string is rolled above the pulley. So here the tension T, and similarly here tension will be T. This is the tension. Now for individual blocks, we have to take the frame of reference, or we have to say that point center of mass, or you can say the point of reference. So we take this and we draw the free body diagram. So assume this is the mass of M2. Now what is acting downwards? M2G is acting downwards and tension is acting upwards, T. If this M2 block is heavier than M1 block, then the acceleration will be downward. So this is the acceleration. Now we have to make the equation. So for this, what will be the equation? M2G minus T is equals to M2 into A. How we derive this? We derived by using second law. F net is equals to MA. What is the net force acting? Downwards. There are two forces acting, tension force and gravitation force. Which force is dominating? Gravitation. So F net is equals to MA, M2G minus T is equals to M2A. Now similarly draw the free body diagram for M1. As the string is the same, so the tension will also be same. This is the block M1. Above there is tension T and down there is M1G. Is there any another force? No. Now in this case, M2 block is moving downwards. So M1 block will move upwards. This will move upwards with the same acceleration A. So here this time the block is moving up. So tension is dominating. So here what will be our equation? T minus M1G is equals to T minus M1G is equals to M1A. Now from the second law video, what you have to do is, this is the equation number 1 for this body and equation number 2 for this block. We have to add these both equations. If you add this both, tension gets eliminated. So here what we get is M2G plus, sorry here it's minus M1G is equals to M2A plus M1A. We add these both equations. So M2G plus minus M1G. So plus and minus equals to minus. So M2G minus M1G is equals to M2A plus M1A. Now you take G common here and A common here. So G into M2 minus M1 is equals to A into M2 plus M1. Our goal is to find the acceleration. So A is equals to, this M2 minus M1 comes over here. So this becomes M2 minus M1 upon M1 plus M2 into G. Now this is the short trick of finding the acceleration. This formula we have to remember. A is equals to M2 minus M1 by M1 plus M2 into G. This formula if we use, we can find the acceleration of this system. Now we got the acceleration. We have to find the tension. If you, this is the acceleration. From this acceleration formula, we have to find tension. So these are the two equations over here. A is equals to M2 minus M1 by M2 plus M1. Minus M1 by M1 plus M2 into G. This is the formula for acceleration of individual block. Now we know the acceleration, we have to find the tension. So take any one equation, either equation 2 or 1. Either equation 2 or 1. So assume equation number 2. T minus M1G is equals to M1A. T is equals to M1 into this minus G minus M1G, I'll put that side plus. So M1 into A. A value we know, this is the A value. M2 minus M1 by M1 plus M2 into G. This is M1A and this minus will go that side as plus M1G. So T is equals to M1 into M2 minus M1 by M1 plus M2 into G plus M1G. Now if you open it, you will get M1 M2 minus M1 square into G plus M1 by M1 plus M2. Now M1 minus M1 M2. So M1, if you multiply with M2, this one will get M1 M2 and this one minus M1 whole square by M1 plus M2 plus this M1 minus M1G goes that side as plus M1, the equation which we got. Now what we have to do is, as we did this, so we got M1 M2 minus M1 square by M1 plus M2 into G plus M1G. So now we have to add these both. To add these both, what we do is we take the LCM. How do we take LCM? So here we'll get M1 M2 minus M1 square plus M1 square plus M1 M2 by M1 plus M2 into G. Minus M1 square and plus M1 square gets cancelled m1 m2 plus m1 m2 is equals to 2 m1 m2 by m1 plus m2 into G. This is the tension. So I'll explain what I did again. We got the acceleration m2 minus m1 by m1 plus m2 into G. Now this acceleration value we took and we substituted in one equation. For example, in second equation, t minus m1g is equals to m1a. So if you keep this m1g over there, it becomes m plus m1g. So t minus m1g is equals to m1a. A value we substituted over here. This is the value of a. Then this m1 into m2 minus m1 square. m1 into m1 is equals to m1 square by m1 plus m2 into g plus m1g. Now we have to add these both. How we'll add? This is the denominator 1. So we do LCM. This thing we multiply at the top. So m1 into m1 again m1 square. m2 into m1 is equals to m1 m2. So m1 m2. So minus m1 square and plus m1 square gets cancelled. m1 m2 plus m1 m2 by m1 plus m2 is equals to t, and t is equals to 2 m1 m2 by m1 plus m2 into g. These are the formula. First formula is for acceleration. Second formula is for tension. But for solving Pulley problems, we won't be using these two formulas. These two formulas are simple, like if they give a simple Atwood machine, this acceleration and this tension formula are restricted only for Atwood machine. If there is a complex problem which we'll be discussing in the video later on, then these two formulas will be difficult to use. So this was how we got the acceleration and tension. Now one more important thing. For example, this is the system. Here there is tension T, here there is tension T. So the tension for this string, this is also one string. This is one string. Over here this is the same string, but over here the same string is different. This string is called pulley string. So for the string of pulley, if this is T and this is T, the tension over here will be 2T. And why 2T? Because this is one string over here and this is another string. See, actually the string is same, but here also, this is also one weight. This weight has the tension over here and this weight also has the tension over here. So combine them, you get the tension 2T. If you want to find the tension for this string, what you do is, this tension value multiply into 2. So tension for pulley, you will get 4 m1 m2 upon m1 plus m2 into G. This is the tension for pulley, this one. That is the tension. So acceleration we got by using the equations and substituting this in this equation, we got the tension value. Now this was all about the concept. Now we will be solving some questions regarding this Atwood machine. So let us move on to the first question. Let us see. So now we have our first question over here. Two masses 8 kg and 12 kg are connected by two ends of a light inextendable string that goes on a frictionless pulley. Find the acceleration of the masses and tension in the string. We have to find the acceleration and the tension. So there are two masses. One is 8 kg and one is 12 kg. So let us draw this pulley. This is 8 kg and this is 12 kg. Are connected by two ends of a light inextendable string. It means that if there is a weight over it, it won't extend more. It will just go down. That goes on a frictionless pulley. It means that if it goes down, there won't be any extra force required to pull the string downwards. It is frictionless pulley. Find the acceleration of the masses and tension in the string. So we won't be using that formula over here. Even if you want, we can use m2 minus m1 by m1 plus m2 into g. If you use that formula, 12 minus 8, 4 by 20 into 10, 2. So acceleration you will get 2 meter per second. So according to this, A is equals to 2 meter per second. This you will get the answer. But what is the detailed way? How will you actually solve this question? That we are going to see. We will be making the equations and we will be solving it. So acceleration. Take this 12 kg mass. Draw the free body diagram. Here it is 12G and up it is tension T. Same also here also it will be the tension T and here it will be 8G. So let us make the equation. Here if you make the equation, 12G minus T is equals to 12A, and here T minus 8G is equals to 8A. if you add these both equation, 12g minus 8g, 4g is equals to 20a. What is the value of g? Value of g is 10. So 40 is equals to 20 into a is equals to 2 meter per second square. So a is equals to 2 meter per second square. We got. This is the actual way how we have to find the acceleration. Now there is one more method of finding acceleration. So what we have to do here is, we know the formula F net is equals to ma. We have to find the acceleration. So a is equals to F net by m. So now if you consider this whole pulley plus the mass plus the top as a system, then if you add the total force, what will you get? Here the 12 kg is moving down with 12g and 8 kg is moving down with 8g, moving up with 8g. So here this is plus 12g minus 8g. What is the net force? The net force is downwards. How much? Plus 4g. If you assume downward as positive and upward as negative, so the net force will be plus 4g. So F net is what? 4g by total mass 12 plus 8. Total mass is 20 by 20. So g value is 10. So you will get again acceleration is 2. So for finding one answer, there are 3 different ways. By using that formula, by doing it in step by step by this method, and by the F net by m. This is also one short trick which you can use. So again, what happened here is, there is 12 kg block which is moving down with 12g and 8 kg which is moving up with t. So what is the net? 12g and 8g. The net is 4g downwards. 4g is the net force and the mass, total mass is 20. So acceleration is 2. This also we can use if we have to find acceleration alone. But here we have to find the tension also. So we can same use that formula 2 m1 m2 by m1 plus m2 into g. But still, as we did this method, we will be finding tension also in this method only. So tension, take one equation. Let us assume the second equation. So T minus 8g is equals to 8a. T minus 8g is equals to 8 into acceleration is 2, 16. T is equals to 16 plus 8g. G value we are assuming as 10. So T is equals to 16 plus 80 and T is equals to 96 Newton. This is the value of tension, 96 Newton, and the value of acceleration is 2 meter per second square. Also we can use that formula 2 m1 m2 by m1 plus m2 into g. 2 into m1 m2, 12 8 96 by 12 plus 8 20 into 10, 0 0 2 2. Then also tension is equals to 96, tension is equals to 96. So you have multiple ways of finding the same thing. So here they have given find the acceleration of masses and tension. So acceleration is 2 meter per second and tension is 96. So acceleration of masses. So assume this 8 kg is the block of mass, first mass, and 12 kg is second mass. So acceleration of first block is equals to 2 meter per second square upwards, and acceleration of second block is equals to 2 meter per second square downwards. Direction is important. So this is the question number 1. Let us move on to the next question. Let us see. So now we have our next question over here. Two bodies of masses 4 kg and 6 kg are attached to two ends of a string passing over a pulley. The 4 kg mass is attached to the floor by another string. The tension in the string T1 is. So this is the question given over here. So there is a pulley and the string is passing over the pulley like this. One is 4 kg and one is 6 kg mass. And this 4 kg mass is actually tied to the floor or to the tabletop wherever it is tied. So because of this, they have given here attached to the floor by another string. So this statement means that first conclusion which we can make is the blocks are at rest. The blocks are at rest. Why? Because the tension, see what happens over here is the 6 kg as the force is applied over here 6g. So the block tries to go down, but because of this string is also, it wants to go up but it cannot because it is attached to the bottom. So if we draw the free body diagram of the 6 kg, here if we draw this 6 kg, Here there is 6G and top there is tension T. Down the force is 6G and at the top the tension is T. But here what is happening is the block is not moving. So first what we can say is T is equals to 6G. This is our first equation. T is equals to 6G. Now this same string is passed over the pulley to the 4 kg. Now if we draw the free body diagram of 4 kg, what is happening over here is the tension T1 is acting downwards. So there is a tension T1 over here plus the 4 kg's own weight 4G is also acting downwards. 4G. And what is supporting the top? The top is supported by tension T. And here one more information, that we have to assume G is equals to 9.8. So here tension 4 kg block, the 4G is acting downwards, the tension T1 is acting away from the point downwards, T1 comma 4G, and it is balanced by a single thing, that is T. Now because the block M1 4 kg is not moving, upward forces and downward forces are cancelled, so it is not moving, so we can say that T is equals to T1 plus 4G. Now we know that T is equals to 6G, so 6G is equals to T1 plus 4G. 6G minus 4G is equals to T1. T1 is equals to 2G. They have said us to take G is equals to 9.8. So T1 is equals to 2 into 9.8, which is equals to 19.6. They asked us the tension in the string T1 is. So T1 is 19.6 newtons. 19.6 newtons. So what we did over here, as they have given that the mass is attached to the floor. The mass is attached, it means that the 6G is trying to go down, but it cannot go down because it is fixed from over here. It is trying to come down, but here it is fixed, so it can't come down. So 6G is equals to T. So from here we got that T is equals to 6G. Now for the 4 kg block, mass 4G is acting downwards, the weight is acting downwards, and tension T1 is also acting downward, but it is not able to move because it is fixed over here. So, and it is all balanced by the tension T. So T is equals to T1 plus 4G. T value we know 6G, and we substituted and we got the answer of T1. Now let us move on to the next question. So we have our next question over here. Two masses 8 kg and 4 kg are connected by a string as shown in figure over the frictionless pulley. The acceleration of the system is. So this is our question, and this is given over here. There is a slope, there is an inclined plane at 30 degrees. There is a mass 8 kg and there is a mass 4 kg. Now if you assume what happens over here. So 8 kg block and 4 kg block, what we do is we draw the free body diagram for each and every block. So let us start with the 4 kg block. Now if there is this 4 kg block, the tension is T over here. Tension T, and down this is 4G. So down there is a force of 4G and up there is tension T, and the whole system will be going down by acceleration A. So 4G minus T is equals to 4G minus T is equals to 4A. Similarly, if you take this 8 kg system, 8 kg, the tension is T over here, and the force downward, the downward acting force, here it should be mg, but there is no, see here the forces should act in single plane. Here if the tension is in this frame, then consider this frame as the x-axis. So if this is the mg, so you have to find any component which is in this direction, opposite to the t. So we have here mg sine theta. So that is t, and here it is mg sine theta. So mg sine theta is equals to 8g into sine 30. Sine 30 is 1 by 2. So 8g into 1 by 2. So it will become as 4g. Then here you get t minus 4g is equals to 8a. If you add these both equations, both get cancelled and acceleration is equals to 0. So this system will be at rest. So that is why if you had the question in the mind, why did we take 4 kg as going downwards, why not 8 kg as going downwards? It is because even if you take 8 kg as going downwards, then also all have to get cancelled in the last. That is why here acceleration we got 0 over here. So this was our question number 3, the masses of 8 kg. And see here the question looked big, but what we did was we just used the free body diagram for each and every block over here. And if there is a confusion or if there is a situation where we don't know either the 4 kg will go down or 8 kg, the thing is mg mostly is acting this direction. So we take the body which is actually free. Here the body is not free, it is supported by an inclined plane, but here the body is free to go down. So we usually take that this body is going downward direction and this body is coming in upwards direction. That is a convection, you can say, or we can usually assume it, at least in our videos, that this thing is going downward because there is no surface below it. So gravity acts at its maximum. So this was our question. Now let us move on to the concept of movable pulleys. Let us see. So now we have our next question over here. Before moving on to movable pulley, let us complete this question. This is a good question. So this question says that in a simple Atwood machine, first point, it is an Atwood machine, two unequal masses M1 and M2 are connected by a string going on over a clamped light smooth pulley. So that is a clamped pulley, light pulley and a smooth pulley. In a typical arrangement, M1 is equals to 300 gram and M2 is equals to 600 gram. The system is released from rest. So first you have to find the distance travelled by the block in the first 2 seconds. Second, we have to find the tension in the string. So let me draw the arrangement over here. So before moving on, we are going to assume that M1 is equals to 0.3 kg instead of 300 gram. So here this is 0.3 kg and this is 0.6 kg. Now we have to, the system is released from rest. So from here we can say that U is equals to 0. So first you have to find the distance travelled by the block in the first 2 seconds. Then tension. So you have to find distance in 2 seconds and we have to find the tension. So this was our question over here. So according to this question, this is our Atwood machine with the mass M1 0.3 kg instead of 300 grams and M2 as 0.6 kg. Now we are going to take G is equals to 10 for good and easier calculations. So now this system is released from rest. So what happens is this 0.6 kg block comes down at time 2 seconds. So first let us draw the free body diagram. This is the 0.6 kg. Down it is 0.6 into G. G value we are taking 10. So let it be 6. And at the top we have a tension T. Similarly for 0.3 kg, down let us assume it is 3 and top at tension T. Now for 0.6 the acceleration is downwards A and for 0.3 acceleration is upwards A. First you have to find the acceleration. So up here 6 minus T is equals to 0.6 into A. 6 minus T is equals to 0.6 into A. For this one, T minus 3 is equals to 0.3 into A. T minus 3, as it is going upward, so T minus 3. Now we add these both equations. 6 minus 3 is 3. 3 is equals to 0.9 into A. 0.6 into A plus 0.3 into A. So T is equals to 6 minus T is equals to 0.6 into A and T minus 3 is equals to 0.3 into A. 3 by 0.9 is equals to A. If you multiply both by 10, 30 by 9 is equals to A. Now 30 by 9, 9 ones are 9 threes are 3.3. So acceleration is equals to 3.3 meter per second square. And this acceleration we are getting when we are taking G is equals to 10 instead of taking 9.8. So this we got acceleration. Now first you have to find the displacement in the 2 seconds. So finding displacement, we can use the formula S is equals to ut plus half at square. Ut will be 0 because u is equals to 0. Half into acceleration is 3.3 into time they have given 2 seconds. So 2 square is 4. So 2 ones are 2 twos are. Displacement is equals to 6.6 meters. This is our answer for question number 1. So if this system is released from the rest and then after 2 seconds this 0.6 kg block will move 6.6 meter downward. Actual answer should be 6.5 if you are taking g is equals to 9.8. 6.56 or 6.6 something. So this is our answer which we got 6.6 when we are taking g is equals to 10. Then we have to find the tension. Take any one equation. So let us take equation number 2. T minus 3 is equals to 0.3 into A. T minus 3 is equals to 0.3 into acceleration is 3.3. 3.3. T is equals to 3.3 into 0.3. 0.99. So 0.99 plus 3. So tension will be almost equal to 3.99 or 4. And one point to be noted here is that tension will come 3.99 Newton when the acceleration g is taken as 10. If you take g is equals to 9.8, then you will get the answer close to 3.8 something. So here t is equal to 3.99 when you are taking g is equals to 10 meter per second square. So this is our answer. Now let us move on to the concept of moving pulleys. Let us see. So now we have come to a topic that is movable pulley. So till now what we are seeing is the pulley is attached to the top. But now here what is going to happen is, this will be our pulley. Here is the mass M1. Here is the mass M2. And now what will happen is the pulley will itself move up or down. So here we are introducing the concept of movable pulley. Now for only one thing extra which we need to learn for this movable pulley is that if you want to find the acceleration of pulley, then see, for example, this M2 is going down with an acceleration A1. This M1 is going up with an acceleration of A2. So what we have to do is AP is equals to A1 plus A2 by 2. This is the only extra thing which we need to learn when we are learning about movable pulley. Now if I say it casually right over here, you will not understand here. So for the movable pulley, we have to do some problems to understand the topic. So let us move on to some simple problem for movable. So now we have our question over here. We are given this system, this arrangement, and we have to find the acceleration of each block. So here first we have to mark the tension. So over here for the block of mass M, the tension will be up, T over here. Now this same string is going like this, like this, like this over here, and it is running around this pulley. So here also tension T, here also tension T. But here that string is changing. And what we have learned, T. So here the tension will be 2T. Now listen, this pulley over here is movable pulley, and this pulley is attached over here. This one is an attached pulley and this is the movable pulley. So here we have to use little bit applicative skills, little bit concept. Then if one question you understand the concept, then the rest of the questions are easy to handle. For example, now this is the block of mass M. As I said, see here may it be 2M, 3M, 10M, but this has a support, but this does not have a support. The acceleration continuously acts on this block. So this block will start moving downward and this block will start moving forward. This at least will be assuming it in our window. So this block of mass M, this will go downwards. So assume after some time the block goes downwards over here by acceleration A. Okay, by an acceleration A, this block goes downward. So if this goes downward, this pulley has to come forward. If the pulley comes forward, the block moves forward. Okay. If this comes down, acceleration A, so this string will also come down with acceleration A. This will move by acceleration A over here. So for this pulley also, let us take this as acceleration A. Let us take this as acceleration of pulley AP. Now this AP has two strings. One string will go with acceleration A, and here the acceleration will be A equal to 0. Let me repeat again. If this block of mass m goes down, this will take acceleration from here, even till here. Now this string, if this has to move, usually what would happen if this is a fixed one and this is not fixed? If the pulley is fixed and this string is not fixed, then the pulley stays at its place and the string goes from here and it goes up to there and down. But here this is fixed and this is actually movable pulley. So this requires some acceleration. Now what acceleration is required? We have the formula AP is equals to A1 plus A2 by 2. Now what is A1? A1 is the acceleration of first string. So this is the system, then this is the acceleration of first string and this is the acceleration of second string. As the second string is fixed, so this acceleration is 0. So AP is equals to A1 by 2. And what is A1? A1 is this acceleration. The block is moving down with some acceleration and this is moving down with some acceleration. The string is being pulled by some acceleration. Here also the string is being pulled by some acceleration. Now what acceleration? The acceleration of pulley is equals to A1 by 2. So if here the acceleration is A, then the acceleration of this will be A by 2. But A by 2 does not look much like good for solving. So what we assume here is the mass m is going down with acceleration 2A. So here this will become A. Okay. So AP is equals to A1 by 2. So acceleration of pulley. What is acceleration of pulley? Acceleration of pulley is the acceleration of these two strings combined. So average of these two strings combined together is the acceleration of the pulley. But here this string has 0 acceleration. This is fixed string. But this string moves. After some time, this M block comes over here. So if this came over here, if it took some acceleration A to come down over here, it needs string from here also. Now it will need string from here this side also, but this side it is fixed. So the string won't be extending from this side, rather it will extend from this side more. That is why this is moving with more acceleration, but this will move with less acceleration. Why? Because this is just supported with one string, but this thing has to take the handle of two different strings at a time, because this string won't be working and this string won't be expanding or extending, whatever, but this string will only be moving. That is why AP is equals to A1 by 2. This is the formula which you got. So assume this mass M is moving downwards with acceleration 2A. Here it is mg. Similarly, this block will move towards the right with with acceleration A. So we have to make the equations now. mg minus t is equals to ma. What is A? A is 2A. And over here, tension is only, is there any opposing force over here? No. So here what we have is 2T is equals to ma. Here it is 2ma, so 2ma. This is our equation. Now what we have to do is, if it was usual equation, we add these both. But here we cannot add because here it is T and here it is 2T. So what we have to do is, either this equation we multiply by 2 or this equation we can divide by 2. So here what we get, mg minus t is equals to 2ma, and down we have 2t by 2 is equals to t is equals to ma. Now if you add these both equations, tt gets cancelled, mg is equals to 3ma. Now mm also gets cancelled, a is equals to g by 3. Now we got a is equals to g by 3. It means that this block will move with an acceleration g by 3 to the forward. Here it is g by 3. But for this block, it is moving downwards. So first of all, it will become minus. Second, it is 2a. So 2a means minus 2g by 3. So acceleration of block 1, this block is equals to g by 3, and acceleration of block 2 is equals to minus 2g by 3. Let me explain this concept once again. If this m is going down with acceleration a, this a, as it goes down over here, it will require string from here and here and here. But this pulley is movable. Imagine if this pulley was fixed pulley, and imagine that this thing was not there. Imagine this is fixed pulley. Then what happens? As this moves down, this will go front and this string will go backwards. That is what will happen if it was not a fixed, if it was fixed. But here it is not fixed and it has a fixed string also. So what it does it will require the pulley itself to move forward. If the pulley moves forward, the mass moves forward, thus this and this get compensated. So the answer is A1 is equal to G by 3 and A2 is minus 2G by 3. Let us move on to one more movable pulley question. So let us see. So now we have our next question over here, that we have given this system, this is the system which we have, and then we have to find the acceleration of each block in this system. So here there is a 2 kg mass block which is held by a string which is clamped over a pulley, and then this pulley is a fixed pulley, this pulley is a movable pulley, and this pulley is a fixed pulley, and here also this string is fixed. So first let us find the tension. Now for this block, tension is T over here. The same string is going over here, so tension here also it is T, same over here it is T, and over here also it is T, and over here also it is T. So this is the tension. Now this is T, so this tension is equals to 2T. This is the tension. Now we have to use our applicated knowledge over here. Now suppose this system is left. What happens is this 5 kg block moves downwards slowly, and assume this 5 kg block is going downwards with an acceleration of A. And here what is the acceleration A? This acceleration A is nothing but acceleration of pulley. So how much the pulley will move down, that much only the block will move down. Suppose this is moving down with the acceleration of pulley AP. Now if this is moving down with acceleration A, this will also move down with A, and this will also go with acceleration A. Now one thing to be noted, if this pulley is moving down, then this will need string from both the sides, from this side also and this side also. Again, assume if this is a fixed pulley, then if fixed pulley with the system, if you are moving the system itself, instead of fixed pulley, if this is a movable part over here, this part is fixed. If this is movable over here, then as this pulley is going down, from here also the string will come, from here also the string will come. So if this is acceleration A, from here also with A the pulley comes down, and from here also the string comes down. So this would be the case, but here it is not possible because here this is the fixed one. So now if this string is fixed, what happens is we have to use again the formula AP is equals to A1 plus A2 by 2. Now this is going with acceleration A, but from here the acceleration A is equals to 0. So here also A is equals to 0. But from here the acceleration is coming down, A. Now one thing we should remember in this formula, that A1 and A2 we should put with sign. With sign. Now AP is going downward, so AP is negative. A2 is 0, so leave it, let it be 0. A1, this A1 is also coming downward only, so it is minus A1, and minus minus gets cancelled. So AP is equals to A1 by 2. Now if this is moving down with acceleration A, this will go with acceleration A by 2. So let us assume this is moving down with 2A acceleration. So this will go with an acceleration of A. So half of this acceleration is equals to AP. If this is AP, so 2 into AP is equals to A1. So this will be opposite over here. This will go with the velocity of 2A. If this is moving down with acceleration, here what is the relation? AP is equals to A1 by 2. So if this is moving with A, then this acceleration will be A by 2. But we are assuming this is going with 2A acceleration, so this acceleration will be A. This thing we have to use the formula and we'll get it. So here as we know AP is equals to A1 plus A2 by 2. Now if you use with sign, this minus minus gets cancelled. AP is equals to A1 by 2. Now what is A1? This is A1. So half of this will equal to this. And why? It is because it is being pulled only from one side, not from two different sides. Now as we know this is acceleration A here, 2A over there, we can directly use our own method. So for 5 kg we can take 5g minus 2t is equals to 5a, because the tension is 2t. And for 2 kg block, t is equals to 2 into 2a. 2 into 2a, why? Because t is equals to 2a and a is what? 2a. So a is 2 into 2a. Tension is equals to a into 2. And what is a? A is equal to 2a. So that is why mg we have to use, ma we have to use, m is 2 and a is 2a. Now we have to add these both equations. How will you add it? If you multiply this equation with 2, then what happens is 5g minus 2t is equals to 5a and 2t is equals to 2 to the 4, 4 to the 8a. Now if you add these both, this will get cancelled. 5g is equals to 13a, a is equals to 5g by 13. So this acceleration a is equals to minus 5g by 13 because it is going downwards, and this is equals to 10g by 13. So this is the acceleration of each block. So what we did over here is assume this 5 kg blocks move down with acceleration a. Then this has to get pulled by both the sides, but this side acceleration is 0 because it is fixed over here. So here acceleration is 0, a1 plus a2 by 2, a2 is 0, so ap is equals to half of a1. This is the a1. So that relation we used and we got our answer. Now let us move on to the last question of today's video. Let us see. Now we have our next question and last question of this video. So here you have to find the acceleration of each block, and this is the system which is given to us. So let us start. If you leave this system, now what happens is, this is a fixed pulley, this is a movable pulley. So first draw the tension T. Here also tension T. The same string is going over here, tension T. Here the tension is 2T. Okay. Now this 2 kg block moves downward. Assume this moves downward with an acceleration A. Now if this is moving downward with A, what if this was not fixed? If this was a movable part, this string over here, then this will go like this. If this goes down, so acceleration will go up like this. It goes over here and it goes down over here. This would happen if this was movable. But now this is not movable, this is fixed. So what happens is, this goes down with acceleration A and this will move up with acceleration AP. And AP is equals to A1 plus A2 by 2. Now over here, if this is moving with acceleration A downward, this will also move with acceleration A upward. It had to move acceleration A upward, but what will happen is, since this acceleration is equals to 0, this will become 0. Acceleration of pulley, if this is going downward, the pulley will go upward, so plus. Acceleration A1. A1 is also pushing it upwards, so this is also positive. So AP is equals to A1 by 2. This is the relation which we got. So what happens is, AP is equals to half of A1. If this is moving down with A acceleration, this will move up with A by 2 acceleration. So what we assume is, this block is moving down with 2A acceleration and this pulley moves up with acceleration of A. Now we can easily use our formula to find out. So 2g minus t is equals to 4a. How? 2 into 2a is equals to 4a. And similarly over here, it is 1g. So this is also, see, because the pulley moves up, this block will also move up. So here also 2t minus g is equals to 1a. Now again what we have to do here is multiply equation 1 into 2. So what you get is 4g minus 2t is equals to 8a and 2t minus 2t minus g is equals to a. This gets cancelled. So add this. 4g minus g is equals to 3g is equals to 9a. A is equals to 3g by 9 and which is equals to g by 3. So acceleration is equals to g by 3. Now acceleration A is equals to g by 3. Here it is 2a. So what it will come minus because it is going down. 2g by 3. And this is going up with g by 3. So this was our last question. So what we did over here is, this block went down with A acceleration. So this string will come with A by 2. Why? Because we used this formula and we got. So we assume this is 2a and then we solve the whole question. So I hope you have enjoyed today's video. In today's video we have completed most of the topics of pulley problems from basic to advanced. So I hope you have enjoyed this video. If you have learned something from this video, do like this video, share this video with your friends if you find this informative, subscribe to this channel, and we'll see you next time in the next video. Thank you and goodbye.